Happy return. Operations on functions. All right, so what operations can we actually do? So this is kind of a series in the advanced functions. It's the introductory chapter for students who are doing advanced functions, most likely in grade 12. Now, if you think back, we utilize, numbers and expressions for quite a long time, starting from elementary school and then onwards. Now, once you get into functions, you might start questioning and asking yourself, well, can we do operations? And when I say operations, I mean, can we add? Can we kind of subtract? Can we multiply and divide? Several functions, just as we have done with regular numbers and then with expressions. And the answer is yes. Now, it certainly does change things a little bit, makes things a little bit sometimes more complicated, but we can certainly treat operations on various functions. And so I'm going to just give you examples. It doesn't necessarily mean we can only add or subtract two functions. We can do it to many more, but because this is an introductory video on the topic, so I'll try to keep them to two, but you can certainly expand it to many more. And in fact, if you continue studying math, you might have actually infinite functions at some point where you're going to be adding and subtracting them kind of in series in some way. All right. So our standard form, at least that I have kind of been teaching through these videos, is, we have some kind of an input, so an independent variable. Typically, we like to call it x. And then it goes through, and let's assume that it is a function, okay, that takes in this input and then spits out an output for us. And we've always kind of thought of this function as just one single function. But let me, kind of rewrite this. So I'll kind of change this diagram and then show you that you can have, two functions and then have an operation on it. All right, so let's try that. All right, so here you go. Here we have it. So I've changed this diagram and now it looks a little bit different. Okay, so we have our input. So here is our input coming in. Now this input now is going to get split up. So notice that it can go into two of these functions. So there is f of x function and then g of x function. Now, once you take this, you're going to have kind of two outputs, right? So if you do this, you would have had, let's say if I call this y1 and then I call this y2. So you would have had two outputs coming out. And notice what I put in here is I put a circle, and this is going to be the operation that we kind of have on these particular functions. So now the operation that I can put in here, I can say, well, what if I wanted to add these two functions together, right? And I can certainly do that. Well, what if I don't want to add them? What if I subtract one function from another, okay? So let's say f of x minus g of x, okay? So I can do it in that particular way. What if I wanted to multiply them together? So I can kind of multiply, okay, these together. Okay, and I can divide them as well. So those are the type of operations that you certainly would think, well, yeah, I guess I can do that, right? So for whatever function I might have, okay, I can certainly do something like this. So if I had, let's say my f of x, and my f of x in here, okay, was, let's say 2, x plus, I don't know, and, this would have been maybe x squared, so this is some kind of a quadratic. And then my g of x would have been, let's say something, it could be even an exponential function. So let's say maybe 3 to the x, I don't know, minus 1. So if these are my functions, I could literally say, oh, okay, well, maybe I wanted to add them, right? Maybe I wanted to subtract them. Maybe I wanted to multiply them, okay? So one of these things, now you might say, well, why would you want to be doing that? Well, there are applications where this is kind of useful. And in the advanced functions course, our goal is to try to be familiar and comfortable with these so that when the applications come, we can utilize these tools of functions to our advantage and then solve some pretty neat problems. So if I take these, I can literally say, well, what if I wanted to be able to add these, right? So I can say this is my f of x, and then I can go about and say, well, what if I wanted to add it to my g of x? Well, my g of x is in this case an exponential, so it's like this. And I would get a new function out, so whatever that function, let's call it h of x equals. And here is my operation on it. And of course, you can simplify it if you want to. You can now start adding. If sometimes what happens is you have like terms between the two functions, you can then add them together and then simplify the whole thing. In this case, there's really no like terms to add. So, this function would have been a little complicated, but we can certainly add the two to get a new one out. Now, it may sometimes happen that, when you're starting to add and subtract, it may change, for instance, your range, okay, that you have. And sometimes it might even change your domain. So if you wanted to, for instance, divide, so if you wanted to be dividing the functions, let's say if I took g of x, and then I wanted to divide by f of x. So now the division, obviously in the denominator, we want to avoid zeros. So that would change our actually domain. Maybe we would have to restrict our domain now once we do that. Okay, so those are all the things you normally were accustomed to. So domains, ranges, your inverses might change if you're working on that, okay, or anything else. So that's the goal of these operations. Now, let's take a look at a couple of examples, or a few examples, to see, let's try to add them or subtract them. And we'll start with something a little bit simpler maybe than this, okay, to get us going. So here are two functions, so f of x and g of x. Notice that they're just lines. So one has a positive slope, goes through -1. The other one has a negative slope, and it goes through +3. So what if I now took these, and let's say I started to apply some kind of an operation on them. So for instance, I wanted to come up and say, okay, well, what if I take my two functions, so here's my f of x, and now I start adding it up. Now in this case, what I'll have, so this is -x plus 3, so these are my two functions, now added up together. And as I mentioned above, okay, if we do have like terms, we can simplify them. Now you would probably guess that, well, if I'm adding two lines together, then most likely my result is still going to be a line. And if I'm subtracting the two lines, again, my result should be still a line. Now, if I multiply them, well, that's interesting. If I start multiplying these, then I'm not really going to get a line back, right? Because I'm most likely going to get a quadratic. So let's take a look, just so to kind of show you that you can have this combination of two functions. So if I'm going to be adding these together, so 2x and then minus x, I guess is going to give us x. And then -1, so plus the 3, is going to be giving us plus 2. So we have a pretty nice, neat line. So notice now it has a slope of 1 and goes through 2. So if I wanted to map these up all into one, okay, so let's say one graph, and I'm going to do that through Desmos, okay, so our kind of favorite tool, okay, and that way we can kind of see what the addition of this would be. And then we can also subtract, and then we can also multiply. Now in the multiplication, you'll notice, as I said, most likely it's going to turn out to be a quadratic. Now we can also try to divide, but with division, we're going to run into some problems in our domain, yeah, but that's all right. So let's try these. So I'm going to bring out here, so I'll take out Desmos on the side here, and let's put them in. So f of x, so this is how we're going to do it. So this is 2x minus 1. So 2x minus 1. All right, let me zoom in here because it looks like it's really, okay, so just so that we can see that. And g of x is equal to, so this is -x plus 3. All right, so we have that. We know that they're intersecting. And now let's take a look and start all these operations. So what if I added them? So let's say if I went f of x plus g of x. That's going to take these two together, add them up, okay, and notice that that's what it's going to look like. So that's my blue. I'm going to swing this over a little bit to the side right there so that we can see the entire picture. All right, so that's my blue that I actually have. Okay, so that's addition. Now, what if instead of addition, I wanted to subtract? So if I do this, so the subtraction is going to give us a different line. Now, what if I wanted to multiply? And I think you just saw that in a moment. Notice that's pretty cool. So 2 lines, and now all of a sudden, well, that's interesting. Now I have a parabola looking downwards, which is coming out from 2 different functions, right? So for this, it's great. Now, in here, if I divide, okay, if I do something like this, and I bring the g of x underneath there, which I'm going to do it right now, okay, now we have, and it should make sense to you, because if I take f of x divided by g of x, so now all of a sudden we have kind of, remember if the parent function 1 over x, okay, is going to start playing a role in here. And notice that it's actually not defined, okay, at one of the values right there, right? So this keeps approaching, okay, so it's going to be approaching here. It looks like it keeps going up, and it's approaching, okay, it's getting closer and closer, 2.945, and it gets closer and closer and closer, okay? And here it looks like it's getting closer to 3. So that's what's happening there, right? Okay, and we can kind of see, okay, what number that will actually be. All right, and we can test that out because g of x is in the denominator, and indeed if we would solve for the denominator for the undefined, and then the undefined would actually be 3, okay? So in here, so this is what we have there. That's kind of how it looks like. So that's the idea behind these operations. Now we can take these operations and extend them further to many other examples. They don't have to just be lines. They can be any functions that we take on. So here's another example, right? So we have a quadratic. So notice it's a quadratic which has a vertex at -2, -1. And then we have an exponential, which is 2 to the x. Now, if I take operations, so if I add them or subtract them, okay, multiply them and so on, you know, we are going to get new ones. Now, what I wanted to also point out to you, sometimes when you have 2 functions, what happens is if you're going to be adding them, one of them on the extremes is going to take over, okay? So either at -infinity or +infinity at some particular point. So it changes the dynamics of how these functions work. But that shouldn't be a surprise. If we're going to start adding, subtracting, or multiplying things in terms of functions, then we might run into some small problems. So I'm going to also take this on decimals. Okay, I'm going to bring decimals back in here. And in this case, so let's say my f of x is equal to, so I have x plus 2 squared and then -1. So notice that's not a surprise. It's a parabola, okay? It has a vertex at -2, -1. So we're very used to these now. G of x is equal to, and now this is an exponential, which kind of should blow up on us. So those are the 2. But now, I'm going to swing this out of the way here. If I take these 2 functions, and now I start adding them up. So let's do that. So if I take f of x, okay, and g of x, notice what happens here. So it's the black one. So it looks like as you go to the negative side, the exponential function decays to 0, right? So as you get further and further, and the parabola actually starts to blow up, okay? It goes into the positive. So notice on the negative side, when we added these together, then what we have, or what we see is, that really our addition, so f of x plus g of x, approaches our f of x function because our g of x goes to 0. Now on the opposite side, as x gets bigger and bigger, it looks like our function is going to be approaching 2 to the x, the exponential. That again should not surprise you because 2 to the x grows much faster than the parabola. So I'm going to go up here and then you'll notice. So notice the kind of purplish line starts, okay? That's my 2 to the x. And then the black line starts to get closer and closer. And in fact, it's going to look like it's touching it directly as you get further and further. Okay, so notice here, it looks like it's literally starts to approach, okay, my 2 of x. And then on the other side, okay, if I go in this direction, okay, further and further, it basically starts to take on the parabola. So it's like a parabola and then a blow up of an exponential. So that's the addition that we see. And of course, you can do this with the function. I mean, this is the beauty of decimals, that you can kind of just keep going like this. Okay, so let me get now closer, kind of come back here, all right, to our original. Now, what would have happened if I subtracted them? So if I did this, so that's what happens here. So there looks like there's a little bit of a change, but ultimately, so within that change, due to the subtraction, okay, notice what happens. It's a very cool thing that it actually starts to, okay, that the g of x, because we made it negative, so the exponential goes down. So it's like it's following the parabola, then it tries to follow it, but because of the subtraction, g of x, and then it just kind of drips over and then goes in that direction because we made the exponential negative. So those are some kind of the cool things that you can see, and utilizing decimals, which I hope that your teachers use as well, or a tool which is similar, that you can visually kind of get some concept of it. Now, you can, of course, as I said, you can multiply these together as well. Okay, so in the multiplication side, this is what happens. All right, so in the multiplication, notice the black, okay, because we are multiplying the exponential multiplied by the kind of quadratic, okay, on the left-hand side goes to 0. Okay, so because the exponential takes over on that side, now it's multiplication. And then on the right-hand side, okay, notice that it does start looking, okay, like the exponential, but it looks like it's gotten shifted a bit. But that's because of the multiplication by the f of x. All right, so that's what you see there. And so that's neat. Finally, one other thing that you can do if you are given kind of functions, but now let's say maybe they're restricted and you don't even know what they are. So maybe they're just graphs like this. So in this case, if you're going to be adding them or subtracting them or maybe multiplying, you can still do that. It's a little bit harder. So in this case, if we're adding them, so what you do is, okay, if you're given this at some point and you're trying to see, don't forget that at the end of the day, you can take the same values like these ones. Let's assume that this is, let's say this is 1, this is 2, this is 3, and this goes 1, 2, 3, and then -1, -2, -3, and the same thing here, -1, -2, -3. So you can certainly add or subtract directly from a graph if it's given. So you can take the point, so notice this is a 2 here, this is a 1, so if we added them up together, it would have given us a 3, so it would have shifted this up. Okay, now these look like they're actual lines, so it makes it a little bit easier for us to do. So I'm going to take the end points. So for instance, I can take this, that's a 3, and this looks like it's a -4. So if I added them up together, so 3, -4, this would have been right here. And now notice I can draw the line right through, and that would have been kind of the addition of the two lines. Okay, now domain is restricted between -3 and 3, and that's what we would have had. Now, if we wanted to subtract we can certainly subtract. You don't have to always say f of x minus g of x. It can be the opposite. So you can subtract these. Now, if we were subtracting these and you were doing it on a graph, in this case, you take, so your g of x, which is 1, minus f of x at that particular point is 2. So 1 minus 2, which would have given us negative 1. So this would have shifted it here. Now, g of x, so minus 4 right here. And then this is 3, so minus that. So that would have dropped it all the way to minus 7. So that's actually, so that's 1. So another 5, 6, so that's right here. So this line, in terms of a subtraction, would have looked kind of funny like that. All right. Now, multiplication, you can also do that. You can take the points. Now, you're going to need few more points, okay, in this case, to try to get that multiplication. You can choose them arbitrarily just to get a feel for it. So if you multiply these, so let's say f of x times g of x, we would have gotten, so from these points, so that's 1 and 2, so that's still 2. So that's where it would have started, at 2. It's a multiplication. Now, at x equals 0, so notice it's negative 1 times 2, which is negative 2. So this would have dropped it down to here. All right, and then let's say one more. Okay, and that would have been, let's say, 3 times the negative 4, which is negative 12. Well, that would have really dropped it. So that was 7, so 8, 9, 10, 11, 12. So it looks like, you know, so this kind of just starts to boil down like this, okay, and then it starts to skyrocket downwards. And because these are two lines, when you multiply two lines, you're going to get a quadratic out. So we would get something like that. All right, you can put some extra points there if you wanted. You can kind of approximate them through and then sketch what you need. And you can also divide. So you can do all kinds of wonderful operations, and this is meant as an introductory video to this concept to make you realize that, hey, I can add, subtract, multiply, maybe even divide functions as well, and then see what happens and then learn from those. Now, you don't only have to do it to 2. You know, this diagram, I can ultimately change this original one. You know, I can have 3, I can have 4, I can have 5, I can have, you know, infinitely many functions. It just gets harder and harder to grasp, and then we need more and more graphing tools to really get a grasp of what's happening, right? So with these ones I presented, okay, even, you know, something like this from quadratics and exponentials, okay, great, you know, we can still kind of approximate and get it. But once you start multiplying and you have many more functions than just 2, it becomes a little hairy. And most likely, kind of in advanced functions, you probably are just getting introduced to these topics. And the idea is, if you do ever need the tools, you have been exposed to them, and then you can extrapolate from what you've learned. All right. Okay, so I hope that this was helpful on the introduction to operations on functions. And that kind of ends this particular first chapter on advanced functions, right? So that's your introduction. Okay, thanks for watching. See you in future videos. Cheers, everybody.